Unbelievable inventions that change the world. The first commercially successful internal combustion engines were invented in the mid-19th century. The first modern internal combustion engine, the Otto engine, was designed in 1876 by the German engineer Nicholas Otto. The term internal combustion engine usually refers to an engine in which combustion is intermittent, such as the more familiar two-stroke and four-stroke piston engines, along with variants, such as the six-stroke piston engine and the Wankel rotary engine. An internal combustion engine is a heat engine in which the combustion of a fuel occurs with an oxidizer in a combustion chamber that is an integral part of the working fluid flow circuit. In an internal combustion engine, the expansion of the high-temperature and high-pressure gases produced by combustion rotating piston present inside chamber and producing kinetic energy to rotate the gears. Various scientists and engineers contributed to the development of internal combustion engines. In 1791, John Barber developed the gas turbine. In 1794, Thomas Mead patented a gas engine. Hydraulic machine. Hydraulic machines use liquid fluid power to perform work. Heavy construction vehicles are a common example. In this type of machine, hydraulic fluid is pumped to various hydraulic motors and hydraulic cylinders throughout the machine and becomes pressurized according to the resistance present. The fluid is controlled directly or automatically by control valves and distributed through hoses, tubes, or pipes. Hydraulic systems, like pneumatic systems, are based on Pascal's law, which states that any pressure applied to a fluid inside a closed system will transmit that pressure equally everywhere and in all directions. A hydraulic system uses an incompressible liquid as its fluid, rather than a compressible gas. Wheels and wheels. A wheel is a rotating component that is intended to turn on an axle bearing. The wheel is one of the key components of the wheel and axle, which is one of the 6 simple machines. Wheels, in conjunction with axles, allow heavy objects to be moved easily, facilitating movement or transportation while supporting a load, or performing labor in machines. Wheels are also used for other purposes, such as a ship's wheel, steering wheel, potter's wheel, and flywheel. Common examples can be found in transport applications. A wheel reduces friction by facilitating motion by rolling together with the use of axles. In order for wheels to rotate, a moment needs to be applied to the wheel about its axis, either by way of gravity or by the application of another external force or torque. Early wheels were simple wooden discs with a hole for the axle. Some of the earliest wheels were made from horizontal slices of tree trunks. Because of the uneven structure of wood, a wheel made from a horizontal slice of a tree trunk will tend to be inferior to one made from rounded pieces of longitudinal boards. The spoked wheel was in continued use without major modification until the 1870s, when wire-spoked wheels and pneumatic tires were invented. Pneumatic tires can greatly reduce rolling resistance and improve comfort. Wire spokes are under tension, not compression, making it possible for the wheel to be both stiff and light. Early radially spoked wire wheels gave rise to tangentially spoked wire wheels, which were widely used on cars into the late 20th century. Cast alloy wheels are now more commonly used. Forged alloy wheels are used when weight is critical. Electricity. Electricity is the set of physical phenomena associated with the presence and motion of matter possessing an electric charge. Electricity is related to magnetism, both being part of the phenomenon of electromagnetism, as described by Maxwell's equations. Common phenomena are related to electricity, including lightning, static electricity, electric heating, electric discharges, and many others. The presence of either a positive or negative electric charge produces an electric field. The motion of electric charges is an electric current and produces a magnetic field. In most applications, Coulomb's law determines the force acting on an electric charge. Electric potential is the work done to move an electric charge from one point to another within an electric field, typically measured in volts. The study of electrical phenomena dates back to antiquity, with theoretical understanding progressing slowly until the 17th and 18th centuries. The development of the theory of electromagnetism in the 19th century marked significant progress, leading to electricity's industrial and residential application by electrical engineers by the century's end. This rapid expansion in electrical technology at the time was the driving force behind the Second Industrial Revolution, with electricity's versatility driving transformations in both industry and society. Electricity is integral to applications spanning transport, heating, lighting, communications, and computation, making it the foundation of modern industrial society.